obtuse.
Anything greater than 90 and less than 180 is obtuse.
Yeah.
All right. So angle JFL. JFL. Use your protractor. Line up the bottom's edge of the protractor on this line right here.
Okay.
And read the bottom scale. Because in this case, we want this angle from here to here.
Yeah.
It looks it looks almost 90 degrees, but it could be a little bit less.
Yeah.
What's your protractor say?
It's getting like about 89-ish.
And that's reading the top scale, right?
Yeah.
Okay. So I would call that angle 89 degrees.
All right.
And classify it as acute, obtuse, right, or straight?
That would be obtuse. No, it'd be acute.
Acute is correct. How about angle GFH?
All right. G.
And it doesn't really matter where you place the bottom of the protractor. In other words, you could place it so that it lines up with GFL, and that's what I think is the easiest thing to do. But you could also place it so that it lined up with HF, but it makes it a little harder because this ray isn't extended.
Yeah.
Whereas from this picture, this might be extended far enough that you can actually read it on the protractor if you line the bottom up here.
Yeah, I'm getting about 55, I think.
Okay, for this angle right here?
Yeah.
Okay, so put 55, and then what kind of angle is that?
Acute.
Okay. GFK. First of all, is that acute or obtuse?
It's probably obtuse.
Okay. Again, line up the bottom with this and figure out which scale you need to use to get the acute or the obtuse angle.
All right.
So as long as you recognize that it's obtuse, you can't really make a mistake on that scale.
Yeah. So it's about 130, about 133.
Okay. And then finally, GFL. GFL. What kind of angle is that?
That's a straight angle, so it'd be 180.
Okay, you got it. Okay. 15 and 16. Give another name for the angle in the diagram below. Tell whether the angle is one of those four. And ACB. What kind of angle is that?
ACB, that is a right angle.
Okay, because that little thing right there, that red thing,
yeah,
that's the only way you really know it's a right angle. And in fact, in all of geometry, they always point out that you have a right angle if it is a right angle. In other words, if they give you a figure and they give you something like this and they put a line that looks like a right angle, but they don't put a right angle thing there, then you cannot assume that it's 90 degrees. However, if they put a right angle thing, then I know this one's 90, which also makes this one 90. So sometimes you can assume it's a right angle, but only if it's up against another right angle that is specified as a right angle. Okay, what about angle ABC? You just have to identify it. You don't have to measure it.
Wouldn't that still be a right angle?
Well, could I draw? We're talking this angle right there.
Okay.
Is that acute, right, or obtuse?
It looks acute.
Correct. Correct. And that's all you need to know. And we don't know how big it is. We don't need to know that for this problem, what its measurement is. All right, let's see what else next. 21 through 29, odd. So 21, which is a correct name for the obtuse angle in the diagram?
ACD.
Yep.
Okay.
Even though this diagram is a little misleading, it almost gives it perspective. In other words, you could imagine that that's the corner of a wall and that that's a right angle actually also, even though it's obviously not a right angle in our diagram, and you can't assume there's any three-dimensionality here.
Yeah.
You have to assume that everything you're looking at is two dimensions. So whatever that angle is, it's acute. Okay. And 23. What's the measurement of ADC?
ADC, using protractor.
It's the sum of these two angles.
Yeah, that would be 65.
Okay, good. Okay, now we get to the point in geometry where about half of geometry is algebra.
Yeah.
Okay, and when you're solving problems like this where there's a variable involved, the idea is to write an equation and solve for x. Okay.
Yeah.
So if they're telling us that WXZ, this angle right here, is 80, what equation can you write?
So WXZ.
What has to be true? In other words, from the previous problem, we figured out that the outside angle was the sum of the interior angles.
Yeah.
Well, that's what the equation needs to say here.
Okay.
What's the sum of the interior angles going to look like? There's one angle. Add the other angle to it.
Plus 3.
What's the other angle?
3x minus 5.
And I know the sum of those two has to be 80.
Yeah.
Whoops, I meant to put an equal sign. And now we have a simple equation we can solve. Let's solve it. Let's review some algebra. What's the first step in solving this equation?
Combining like terms.
Yeah, although I kind of like getting rid of denominators and getting rid of parentheses.
Okay.
Always as my first step. So the first thing let's do is get rid of the there's no denominators, so we can get rid of the parentheses. When I remove the parentheses, what do I have?
X plus 5 plus 3x minus 5 equals 80.
Next step?
Minus 5 equals 80. And then,
now is where you want to gather like terms.
Yeah, so minus x from 3x, would that work?
Hold on. Where are you getting the minus from? I got a positive x there. That's 1x. And then that's 3 more. So how many x's do I have?
4x.
Okay.
Okay.
what happens to this plus 5 and this minus 5?
They cancel each other out.
Okay, so I'm left with 4x equals 80. Next step?
To divide 4x from 80.
Divide 80 by 4. In other words, the last step in solving pretty much any equation is to divide by that coefficient. If I divide that side by 4, I got to divide that side by 4. Well,
Yeah.
the 4 is cancel, leaving x. That's why I divided by it. And whatever this number is, which is 20.
Yeah.
Okay? But notice we solved for x, and they want to find y, x, z, so they want to know what 3x minus 5 is.
Yeah.
Well, what's 3x minus 5 if x is 20?
Okay, so you do 20 equals, would that be 55?
Uh-huh.
Yeah.
So that angle is 55 degrees. And this is very, very traditional, typical geometry. This kind of stuff you're going to need to know when you take the ACT test, all that good stuff. This is a very classical geometry problem. And like I said, half of geometry ends up being algebra.
Yeah.
Okay, let's see. What was next here? 27. Okay, so they're saying, well, I'll see if you can do this one on your own.
Okay.
Remember, the goal is to write an equation
Yeah.
that we can solve. So what can we say?
2x plus 6 equals 80.
No.
No.
Plus 80.
Oh, plus, okay.
In other words, this angle plus this angle make XYZ.
Yeah.
Telling us that XYZ is 140. So 2x plus 6, and I'll put parentheses around it, but you don't really need the parentheses in this case. The only reason I used parentheses before was it's clarifying it. It's for clarification. But you don't hardly ever need the parentheses around the first term. Sometimes you might need it around the second term, but not in this case. So you can see that 2x plus 6 plus 80 equals this angle XYZ, which they've told us is 140. Now solve that.
Okay,
You can
wouldn't you
use your calculator.
subtract 6 from itself and then 80?
Well, what I would do would be, first of all, combine those two before I move to the other side. Okay? Just because it kind of makes it easier. So 2x plus 86 equals 140. Now what's the next?
And then subtract 86 from itself and 140.
So 2x equals 140 minus 86, which is 54. And finally, the last step
is to divide 54 by 2.
Yeah, divide both sides by 2. In other words, the singular principle of algebra is that whatever you do to one side, you have to do to the other. So I can't just divide 54 by 2. I have to divide both sides of my equation by 2. Just like up here, I subtracted 86 from both sides of the equation. So you get 27. X equals
27.
And that's all they wanted, was the value of x. Okay?
Yeah.
Let's see, that was 27. Let's do one more, if you don't mind. 29.
Okay.
Just we're out of time if you only want to do a half hour. But we started a little late because it took a while for you to get the program working. So let's do one more. Okay, WZ bisects XWY. What does that mean?
That it,
What can you say about other angles in this diagram? Find the two angle measurements not given. Well, what's one of those angles?
ZWY.
And what is it? By definition, it also has to be 52 degrees. Because what bisect means is it splits it in two equal parts.
Yeah.
So we know this is 52. And what's another angle that they didn't tell us it was that we can now say what it is? What's XWY?
52 degrees.
No, this one. XWY. That obtuse angle.
That would be the total of those two added together?
Yes. And we know, first of all, that it's got to be over 90, right?
Yeah.
It wouldn't make sense if you get an answer less than 90. Because we can see it's obtuse.
And it equals 104 degrees.
There you go. Okay, so we got through 29. I don't know if these have to, is this for tomorrow or we have another appointment scheduled on Thursday, looks like?
Yeah.
Or Friday, not till Friday. Okay.
Yeah, it's on Friday.
Okay. So, well, I'll let you be. And like I said, on Friday, if you want to just tell me what page you're on and which problem, that should work. Because I have a different edition, because I think I do at least. Yeah, because this was on page 26 instead of 28. But that's okay. I generally have the same problems. So I don't I'll need you to send me a picture of them.
Okay.
Okay? All right, Kendall, I will talk to you Friday. And on Friday, once again, I will just text you the meeting ID number, and I'll bet it doesn't take that long this time. I'll bet it really was updating the software.
Okay.
You know, since it's been a summer. So, okay, I will talk to you Friday.
Yep.
Bye.
Thank you.